50 of the company, so we are completely revenue driven as an organization. So tonight we're going to talk about our flagship product, something that we've been working on since 2015, and that product is called Cardano. And we're also going to talk a bit about how Cardano fits into the marketplace. Where is Cardano at? What is Cardano all about? Okay, so Cardano started as a project of first principles. So what happened is that I've been in the Bitcoin space for long enough to remember a time before smart contracts, a time before Ethereum, a time before Bitcoin was even considered to be real and legitimate. If you go back in history about 7 years, Bitcoin was considered to be kind of a shaky, scammy thing by pretty much everyone in the entire world. There was a very small group of people who loved it and thought it was amazing, and the rest of the people, if they had heard of it, the only context they had is, it's that thing you use to buy drugs off of the Silk Road. That was what they believed. And so basically people said, well, if it's going to survive, it's got to be banned, and it's probably not going to survive, so we'll ignore it. Then something happened. In 2013, Bitcoin got valuable. It went from a few $100 million to $1 billion, and it had this huge surge of people entering the space. And that surge of people started believing that not only is this thing legitimate and real, but it's here to stay. And here's what happens when the market starts believing that something is real. They say it's not good enough. Kind of like the internet. For a long time, it was just this nascent little thing. No one particularly cared about it. A lot of really smart people argued about it, but it was an academic thing. And then suddenly people said, you know, this internet thing, it's here to stay, but the experience is terrible. I can't do much with it. Then the web browser comes. And then suddenly you're able to actually go to web pages. But those pages are boring. They can't do anything interesting. You needed JavaScript. And when you got JavaScript, then you got Gmail. Then you got Amazon. Then you got YouTube. Then you got Facebook. All of these great companies that we basically now spend 80% of our lives, if not longer, on or their localized equivalents. So similarly, in 2013, people started talking about going beyond Bitcoin and going into this notion of programmable finance, the idea of the smart contract. So what the smart contract is all about is saying that transactions are going to be arbitrarily complex. There's always some strange terms and facts and circumstances and other things going on. You know, you could say, okay, if you fix my roof, I'll give you $100, but only on Tuesday. On Wednesday, it's 50. You could do that. That's an example of a contract. People do these types of things all the time. Well, guess what? There's no way I can, as a protocol designer, anticipate your need. So how about I do this? Why don't I give you a programming language, and then you can figure out how to write up your particular financial relationship. This was the idea behind Ethereum, which was the second generation of cryptocurrencies. And basically, it was an experiment. We thought it wasn't going to work. We said, well, we'll go do it for 6 months, and when it fails, we'll go do something else. And it turns out that Ethereum became wildly successful, just like Bitcoin was wildly successful. And people said, this is amazing, we love it. But there's one big problem with Ethereum, is that it cannot scale as a system, nor can any current cryptocurrency scale as a system to millions to billions of users. So you see all these wonderful presentations that people do about the problems, the real problems they want to solve for companies like Samsung and BMW and Intel and IBM, or for governments, things like property registration, things like e-voting systems, things like next generation identity management systems that are fraud resistant. These are real problems, and if you solve them, they make a lot of people's lives better. They make a lot of businesses make a lot more money and be far more competitive. But they also require a certain degree of maturity and a certain degree of underlying service and utility within these platforms to be solvable. And the problem with second generation blockchain technology is they just don't provide that. Like Bitcoin, Ethereum was really a proof of concept for an idea, the idea of smart contracts. But it's not a production system. It's not something meant to go solve all of your problems. So enter the third generation. So back in 2015, we went to the whiteboard and we started sketching out all these problem domains and all these ideas, and we were trying to get to the heart of the matter, saying, what are the collection of problems that we have to solve in order to be able to actually build a system that works for billions of people. As a thought experiment, if we were to go to Venezuela and tear out the entire government and plop in a cryptocurrency to run the whole show, the voting, the driver's licenses, the economy, the credit system, the banking system, how much technology would have to be in that protocol? How much capability would have to be in that protocol to be able to solve that problem? That's what we asked in 2015. Pretty simple question, pretty insane answer, which is a whole lot. And then we said, boy, if we're going to go and try to do something like that, if we're going to actually try to solve such a problem, well then how are we going to solve it? Who's going to solve it? Am I so smart and so arrogant that I believe that I can go and solve all the problems of the world? No, no one can, no matter how good they are, how rich they are. It's a collective problem. It's a huge problem. So we said we need to come up with a process upon which we can find a way to solve these problems, pay for their solutions, and get consensus around them, and gradually, over a long arc of time, years to decades, be able to build such a system. So that was the kernel of the Cardano project, and we settled around 3 pillars. One was scalability. So we need to build a system that works at the scale of billions, as I mentioned, but really when you look at that under the hood, we need to build a system that gets faster and when more people join the system. So BitTorrent is a great example of that. If you download a very popular movie or a very popular series like Game of Thrones, you get it really quickly because lots of people are downloading it. If you download something that's not so popular, you get it slow. That's a protocol that gets faster as you get more users, not slow. And cryptocurrencies need this property somehow, some way. They just need to be able to process more transactions. The network needs to get faster. You need to have more total amount of blockchain data you can store. Okay, that's scalability. That's one of the pillars. Our pillar, but something that needs to be solved. A lot of people working on it. Second, there is not going to be one standard. If it was, it would have been Bitcoin. Bitcoin lost. So there's going to be thousands of cryptocurrencies, and there will continue to be thousands of cryptocurrencies. The names will change, the actors will change behind them. Some will be government sponsored, like maybe the PPOC will create one. Some of them will be built by random weird people over the internet. But the point is that all of these things just have to get along somehow, some way. And when I say get along, that means when you have a token in one ledger, that token is able to transact and talk to another ledger. So for example, you can send a transaction from Litecoin to Bitcoin, or from Ethereum to Cardano, or from Ripple to Dash. Interoperability. And going a step further, interoperability with the legacy financial system. Many of you have bank accounts, many of you have credit cards. Wouldn't it be so nice that you could store your crypto maybe on your bank's ledger? Wouldn't it be so nice if you could put your crypto on your debit card or your credit card? Well, there are some people trying to do this, but it's still a huge challenge. And the reality is there's trillions and trillions of dollars of wealth locked in that system, and it can't quite move between both systems easily. So interoperability is a big legacy problem, and it's a big problem in the cryptocurrency space. Furthermore, interoperability at the enterprise level is quite interesting because we have this idea of private blockchains. Things like IBM Hyperledger, things like Microsoft Bletchley, things like Cadena, things like the Enterprise Ethereum Alliance. And what happens when you issue a token on one of those ledgers? Well, wouldn't it be nice if that can move into the general internet and come back? An example I love to use is, does anybody here ever have played World of Warcraft in their lives? That's how I know the translation's working. Okay, there's a guy in the back, so the translation's working. Good. So if you play World of Warcraft, what do you have there? You have items. You have gold. That's kind of like a token. Wouldn't it be so cool if that stuff you've earned, you can take and bring it into the main network, sell it on an exchange like Bithumb? Why not? Well, that's a private ledger and a public ledger. So how do we get them talking to each other? That's an interoperability question, and there are thousands of these interoperability questions that exist and will continue to exist. So we got to solve that. Finally, the last pillar that we identified is this notion of sustainability. And really that just comes down to the who pays and who decides problem. If these protocols are eventually going to be used as the backbone of an economy, of a government, to control the books of a major corporation like Microsoft or Samsung, they're going to be really expensive to maintain, to evolve, to research. Hundreds of millions of dollars and billions of dollars, because you need new capabilities over time as technology evolves and society changes. Well, here's this thing. It's called the golden rule. Golden rule is he who has the gold makes the rules. So if your goal is decentralization, and you don't have a strategy for who's going to pay the bill for how these systems are going to evolve, then the reality is that you're going to centralize around whoever's paying the bill. Just a fact. If you pay, you get to make the decisions. Second, the evolution of the system, how do we do that right now? We have cults of personality behind leaders. If you're Ethereum, you have Vitalik. If you're EOS, you have Dan Larimer. If you're Cardano, you have Charles. And we say, oh, this is the way we must go. Is that decentralized? No. And even if I'm a good guy, what happens when I get old? I get pretty fat. You know, I'm traveling too much. Might die of a heart attack. Plane might crash. What happens if my replacement isn't a nice guy? Or Dan's replacement's not a nice guy? Or Vitalik's replacement's not so nice? You may have your entire livelihood in this system, and then suddenly you have a key man problem, a governance problem. So the last issue, the sustainability issue, is how do you decide where the system will go without relying upon a central authority to make that decision for you? Because these are global systems with potentially billions of people using them over time. No one person should be given that much power. So these are the three pillars that we identified back in 2015. We'd really like to make a meaningful and substantive attempt at solving. And that encapsulates the philosophical core of the Cardano project. So let's talk about how we intend on solving those problems and what we've already solved. So back in 2015, we realized that the very first thing we needed to do to solve these problems is first make them smaller, so break them into lots of little problems. Second, we needed to engage the universities. So we went about a very aggressive recruiting campaign and hired a chief scientist and lots of cryptographers, and we started writing foundational papers. We asked very basic questions. Questions like, what is a blockchain? You hear it all the time, right? Blockchain, 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 all the time. But what the hell is it? Specifically, what is it to a computer scientist? What properties must it have? What makes it secure? To what extent is it immutable or auditable? Because you hear these buzz phrases, but what does it actually mean? So we wrote a paper called GKL15, Wangare, Nico Leonardis, and Aguilos Kayasas. And in 2015, we gave a definition for what is a ledger. And then we proved that proof of work creates a secure ledger, the heart of Bitcoin. That gives us a baseline. So now we have an idea of what we want to accomplish, and we have an idea of what the people who have come before us have done, and if they work or not. So then we asked ourselves, okay, can we come up with a protocol that satisfies that condition, but then at the same time also satisfies that first pillar, the idea of scalability, so that as you gain users, you gain resources. And so we did a very large literature review. We looked at all these different wonky ideas, some crazy, some practical, some a bit too practical, and we realized that maybe proof of stake has within its DNA the capability to actually accommodate this insane design goal. So we did what all academics do. We did a very extensive literature review, and we said, all right, who's written anything at all about proof of stake? We brought all the papers together, and we brought scientists from 6 different countries and 5 different universities together. And we spent over a year, and we produced our first major paper called Uroboros. But it's not good enough to write a paper, even with bright people. Part of making problems federated, of decentralizing your own ecosystem, is having checks and balances. And the best check and balance in science is this process called peer review. That's the bedrock of what we do at IOHK and how we're building the Cardano project. Peer review isn't putting a paper online and asking random people over the internet for their opinion. Peer review, in a cryptographic sense, is writing a very technical paper and submitting it to either a journal or to a conference that is recognized by the practitioners of that community. In the case of cryptography, there is one community. It's called the IACR, the International Association of Cryptological Researchers. It's a very large organization, many, many thousands of members. All of them have PhDs. They're professors at places like Harvard and Oxford and University of Tokyo. They're all over the world. And every year they maintain conferences. These are peer review conferences. And guess what? If you want to tempt fate, you can submit your papers to them. The flagship conference is in the United States. It's in Santa Barbara over in California. There's also one in Europe. And there's also one usually in Asia. It's called Eurocrypt, AsiaCrypt, and Crypto. And when you submit a paper to one of these things, and these are papers submitted by experts, only about 20% of the time are they accepted. 20%. Vast majority are rejected harshly. Because when you submit, they give you a reason for rejection, and they're not nice about it. Okay, so we said, you know what? It's not just good enough to write this science and to think about things like proof of stake and try to find a way to make it secure and work well and work with our ledger idea. We must take it to the academic community and win them over. And it took us 2 years to do that. So we published, and in 2017, we actually successfully got into Crypto 17, and I went to Santa Barbara with our chief scientist, and we were able to present the paper. Now, that's not the end of the story. That's the beginning of the story for how peer review works. Because once you've gotten in one of these conferences, you wake up the hornet's nest. It's like kicking the bees. They swarm. And every single person can get academic credit for showing your ideas are wrong. What you've come up with has a flaw that they can break, because they too can publish a paper. And if they get enough of them, they get tenure. They get to teach at a good university. They get higher status. They're the guy who broke something prominent and embarrassed the great cryptographer. That's how it works. The other consequence is that you get free labor. It's the closest thing you get to slave labor in the tech world. Because guess what? You're going to have thousands of people running around trying to improve your system, break your system, and none of them work for you. And in many cases, even if you wanted to hire them, you can't. Adi Shamir is the inventor of RSA. He's rich. He has a Turing Prize. It's the Nobel Prize of Computer Science. There is no way that that man's going to work for anybody. He's very happy at his current job. He does whatever he wants to do. He shows up whenever he wants to, and he only thinks about the problems he wants to think about. The only way I can talk to that guy is at Eurocrypt or Crypto, or through the peer review process, or having him read one of my papers and trying to break it. And he's one of the smartest men alive. So this process is amazing if you invest the time to use it. And that's what we decided to do with the Cardano project. And we've already seen great outputs by being accepted. The other thing is we've seen great citation counts. Ouroboros has now been cited over 50 times, and people are actually already starting to build their own protocols using our protocol. I was so excited to see a paper recently called OmniLedger, which was out of École Polytechnique Lausanne and Trinity College. And this paper is a sharding protocol that uses Ouroboros. We never talked to the authors. They just built something. And we all get that for free. So that's the first part of this concept, is identify these grand problems you want to solve with a distant goal, kind of like SpaceX with Mars. We want to go do something crazy. Second, engage a much larger community than yourself that acts as an independent check. Because the reality is there are thousands of these cryptocurrencies, and guys, it's just too hard to know which ones are real and which ones aren't. Everybody's making claims. Secure, thousands of transactions per second. I solved this, I solved that. Quantum resistant, this resistant, that. How do you know which ones are true and real? How do you have time, even if you have the knowledge and skills, to be able to identify that? The power of peer review is that I don't own that system. No one does. The universities of the world have come together for it, and it provides an independent check and balance that the claims my team are making is correct. And now we have allies all around the world who are interested in the things we're interested in. Some are working with us, some are working against the work we're doing. That's okay. We'll solve it together. Now, that alone would be awesome. And if all Cardano ever was just a computer science project that's solving hard problems, that would be fun, but it's not useful. You actually have to build something. You actually have to write code. You actually have to deploy the damn thing, right? So there's many ways to go about that. How do you go about implementing these pieces of paper that have lots of pretty math on them? Well, the conventional way would be to pick a popular programming language like Java or C++ or JavaScript and just go and build it and hope you actually built it correctly. And it works until it doesn't. And when it doesn't, you have the Dow, and hundreds of millions of dollars are lost. Or the parity hack, and hundreds of millions of dollars are lost. Or you didn't actually implement what was in the paper, and it turns out all that work you did to prove something is secure is for nothing. So we realized early on that if we were going to go to the trouble of bringing in academic rigor into our system, that we must build the systems correctly. So we looked and said, well, are there any software engineering techniques that exist that have been around for a while, that are proven, that can allow us to reliably implement our software correctly? Reasonable question. And so we said, well, what industries does it have to work the first time? Now, I travel a lot, usually the window seat. I look at the jet engine. That doesn't get the blue screen of death very often, does it? Doesn't crash very often. Because if it did, the plane would fall out of the sky. And that'd kill me. Not so good. So the people who write the software for that system have to think very carefully to make sure that that software works right always, and the first time. Because if it doesn't work the first time, that's the last time. The same for NASA. They sent a probe to Mars, and it's driving around the surface of the planet. What happens if it crashes? Is somebody going to go and kick it? No, you can't. It's Mars. It might take a little while to send somebody to go and fix it. So the software has to work the first time, or it's the last time. So there's a collection of techniques called high assurance software engineering, and it's been around for about 3 decades. And industries like the aerospace industry, so companies like Boeing, industries like NASA, where they send stuff to space, anything where the cost of failure of the system is in the billions, or the loss of human life, like the brakes on the Shinkansen, for example, or any normal train. Those industries have developed out these software techniques. And we said, boy, wouldn't it be great to take those techniques and port them into the blockchain space and use them to implement the papers we have? Novel idea. So then it's fair to ask, well, Charles, why doesn't everybody do this? Why doesn't the general world do this? Well, here's why. It's horrendously expensive. It's horrendously time-consuming. And it's really, really, really difficult to do. And only a small group of people can do it. Therein lies the dilemma. The things that allow you to do correctly, unfortunately, also are the most difficult to deploy, which makes you the least competitive in terms of getting things to market on time. So you have to make a trade-off and decision. Where on that quality spectrum do you want to live? So we had long discussions about this in 2015 and 2016, and we settled on something like a pseudo-formal approach. So we're not quite where one would be if they're building a space probe, but we're not naked code like your average web application. We kind of live in the middle. And we chose a very special programming language called Haskell. And Haskell's great. It comes out of the academy. It's been around for a few decades. In fact, we loved it so much, the guy who created the programming language, we ended up hiring him because we said, boy, we like it. And so we have a great team of Haskell developers. It took me 1.5 years to hire them. Some of the best in the world. Most of them have master's degrees and PhDs and decades of experience. And we found a way to write these protocols that we have on our paper that we've carefully crafted into Haskell code and actually ship a product. This was an enormous difficult task, and it had never been done before in the cryptocurrency space. As of September of 2017, we were actually able to launch Cardano and Daedalus. It was crazy. We had delay after delay, and every single time we tried to deploy something, it turns out it doesn't work so well on systems like Windows, so we had to build custom tooling and libraries. It was a great journey, a very painful journey. The kind of journey like walking through a field of glass with your bare feet. But it was a worthwhile journey, because on the back end, over time, we know the things we're building are here to last. Because the reality is that whoever wins this fight, the third generation blockchain fight, could end up becoming like the TCP/IP of finance. TCP/IP is a very old protocol. It comes from the 1970s, made by the guys at DARPA. And it's now the heart of the entire internet. They did some things really well, but they did some things not so well. And now, decades later, we still have to live with those poor design decisions. So in my view, it's very important that whatever we do, however we build this stack, that it be designed as best as possible, because if we win, we have to live with the consequences of winning. So that's basically the Cardano project from a scientific and an engineering viewpoint. So let's talk a little bit about why is it useful? What's special about it? Why would a person want to use it? Okay. Well, first off, one of the things we immediately recognized is that if you're clever about the way you design things, you can build two products at the same time. One of them is an enterprise product, and one of them is an open blockchain product. So the enterprise projects are things like Hyperledger and Bletchley and Cadena. These are great, and they're going to be used all throughout industry for all kinds of trust and coordination problems. But right now, we consider them to be a separate thing. They live in their own world, and they're completely disconnected from the blockchain space. So much so that the blockchain people tend to not get along with the cryptocurrency people. They say, we like blockchain, but not cryptocurrency, or vice versa. And we think that's very sad. In fact, what you ought to do is blur those lines a bit. So we're building in parallel to Cardano an enterprise Cardano framework that has built into it the ability to interoperate with the main Cardano ledger. So this is a way of deploying our technology in a private setting for a corporation, for a university system, for a government. That anything you do there, we can find ways of having those things be able to react to the cryptocurrency space in general. So that's the first thing, is build it in a way that people can talk to each other. Second,